All right, good afternoon. Hi, my name is Benedict Gaster. I'm supposed to start exactly on 12, so it's 12 now, so I get enough time. Apparently the stream's going out, and so we're going to do that. I had no idea if I'm in front of the camera. But anyway, so I'm from the University of West of England in the UK. Some of my students are here, which is great. And I teach, and I also do research. At the moment, my research is into the Internet of Things, and I'll talk about what that is, and particularly into radio technologies. But I'm also interested in how that can reach out to communities and actually have an impact rather than just being, as you'll see in a minute, to buy stuff or whatever. But before I start, I want to say, so I'm from England, and I have to say this because it's a terrible time at the moment, and I did not vote to leave the European Union. That was a fucking stupid thing to do. And moreover, this hatred and all of this stuff, we have to work as citizens and everything to stop it because it is horrible. And many of the people that will contribute to open source communities come from all over the world, including these countries that are now banned. And it's just awful. And so I wanted to say that because I'm on the public stance and I need to stand up. I think we all need to stand up and say that all the time and tell our governments and all the time. Thank you. Great. All right. So I said that. And now I want to talk about LoRaWAN and what that means for exploring the Internet of Things. Okay, and this talk will mostly just be introducing you to it. I'm not going to get into lots of really low-level radio stuff, although there is some really interesting ideas around the modulation of that technology and everything. But it also, I think, has a cultural impact. I'll probably talk for way too long, so I'll try to keep it nice and fast. If you do have questions, just ask as we go along. These are the kind of things I'm going to cover, what I mean by the Internet of Things, LPWAN, which is low power wide area networks, LoRa itself, the Things network, which is this amazing open source, crowdsourced community that's come out of Holland and is now approaching on the world, that is encouraging access, open source and free access to the Internet of Things for everyone. And I'm not going to really talk about it very much, but I do have the work that we're doing in Bristol. I just have a link to it really. But the Internet of Things, well, it can mean a million things to different people, and it's the idea, I suppose literally, that we're going to connect devices and together, potentially in a mesh frame network, and then they're going to communicate with other devices, systems, the cloud, and other things via the internet and whatever we might define the internet thing. And I really think that it's a slightly misnomer because in some places you don't need to be connected to the internet at all, right? It could just be an Ethernet cable going to a cloud service and running devices locally. But lots of that technology and the things that we develop over the next few years could apply in these different situations. And okay, I don't like Amazon Dash, but I'm sure many of you have heard of this thing, Amazon. They're quite a good company. I do use them all the time, I'm not going to deny it. But they also make this thing where you can buy, I think it's like $5 or £5 or whatever, €5, and you get a little button that you can press and you attach it to your fucking washing machine and press, when you run out a parcel it is in the UK that a lot of people use, you can automatically buy it from Amazon, it will be sent to you. I mean, the thing's horrific, but it exists. I suppose the most famous one, I lived in the US for a long time, the most famous one that people did was, control it. You can use your phone to control how hot your house is from, I don't know. I'm sure it's useful, but not things. So there are lots of different things. These are the kind of things that have the consumer side of the Internet of Things. But I think the real problem that I have with all of this is that, these are fine applications and everything, but I don't know if we really need to build 1 billion devices just so we can buy something or control the heat in our house, because if that's really it, then I think we've fallen quite short of anything that's useful. So from my perspective, and all reports are saying that over the next 2 to 3 years, we'll have 1 billion devices enabled via the Internet of Things. I don't know whether that's exactly true, what will happen, but by 2030 they're talking, multiple billions, maybe 1 trillion. If that's the case, then we can do a lot better than just buying things, right? It can change our lives. And I don't need to be able to automatically buy some washing liquid. I know how to go to the shop and do that. That's not going to change my life that much. We could, for example, these guys can't go into this thing because it's unstable, there could be gas leaks and everything. We could build devices which we could just parachute in and use them to tell us whether it's safe to go places. I mean, obviously it couldn't tell us it's structurally safe, but it could measure gas levels, things like that, if there's leaks and things like that. That would be amazing, right? After earthquakes, we had one just in Italy not too long ago. And just in Bristol itself, air pollution kills up to about 200 people a year, and there's some parts where Bristol's a very hilly city, and you go into it, and some parts down there where kids are walking to school and they're coughing when they get into school, right? It's really easy for us to build. I mean, you know, you can buy one of these as a little MIDI sensor, but you could buy a NOx sensor, pollution sensors, you know, for very cheap, right? And we could put these in schools for virtually nothing if, and this is the real question, the real thing, if it's easy for those things to get online and to build data and make it easy accessible. One of the real problems that people have is this thing called onboarding, where you come up with your amazing device, you take it into somewhere like a house, say a medical device or a school, and then there's all sorts of ladders and hoops you have to jump through to get it onto their bloody Wi-Fi network, if it even works, doesn't drop out, and things like that. And of course then you have to make sure you're in the right range, whereas the potential is, imagine you just turn up with the device, put it, and it was already connected, because the radio network that you were connecting to was just, covered miles, kilometers for you people here, or whatever. Sorry, I won't get confused and whatever. But imagine we could do that. That would have, could have real implications on that. So one of the projects we talked about here that I've been working on with Bristol City Council and a place called Knoll Media Centre was they developed these little frogs that people could put in their houses to measure the damp, humidity. It's just measuring humidity and things like that in an area. And they did a frog because it made it a bit more what people would think it was the implications. And the first version just used an SD card, right? They just stuck it in, so it's just a Raspberry Pi with humidity. I mean, it's really simple stuff. A little SD card. But that meant that every couple of weeks they had to go and pick up this SD card and do it, and then they had to transfer and do something with the data. These are just volunteers, mostly in community centres, things like that. That's really painful, right, even if they get to it. So then they upgraded it and put it onto a Wi-Fi system. Well, then it turned out, some of these people who live in rented accommodation where damp is a real problem and landlords are not willing to fix it, they don't have Wi-Fi. Right? These are some of the poorest people in Bristol. Some of these people we just talked about in the previous my speech, refugees coming from the most awful places in the world, in terms of war and stuff, not awful, anything else. But they didn't have it, and it was amazing. I think it was something like 62% of the houses they went to in this one area where they were looking at them didn't have broadband or Wi-Fi of any sort. So they couldn't do it. And so it was really annoying, right? That's really annoying. None of those houses could do it. We couldn't do it. The SD card worked, of course, but then you had other problems. So there's lots of things, okay, that I think the IoT could do. There's lots of applications. You've got business that can make you money too or whatever, but I'm less interested in that from my perspective. I'm lucky now to work for a university which it wants to make money, but they don't make me have to make money. Okay, so that was a brief introduction to kind of what I think Internet of Things could do. Some very simple applications. But what is it from a kind of high-level perspective? Well, here on the other side, here on this left-hand side is what we see as the devices that you might build. Mostly I'm thinking of sensors. They don't have to be, but I think if you want them to be very low power and so forth. So these are these little red dots on the left-hand side. Then in the middle, there's going to be some way that we are communicating to. I suppose all of these are actually these middle blue boxes here are the routers. I call them the gateways, and these are the things that are receiving the radio signals from the devices, and then literally these are just repeaters, right? They're really just taking the radio signal, converting it into an IP packet, and then transferring it onto the internet. And once you're on the internet, it's just IP at that point. And of course, clearly, the way that we handle most of this stuff today is we use cloud services, and I'll talk a bit about this later on. The Things Network, which is this organisation out of Holland, that's what they really provide. That's the killer thing that they provide, is they provide an open source and free back-end or backhaul service for routing all of your information from these devices into their cloud services, into their backhaul, and then you getting it back out by Node or MQTT or whatever. None of that stuff is new in terms of technology. It already exists. We know how to do all that stuff, whether it's be Amazon or Microsoft or whether we have open source software. We know how to do these things. And what is the interesting part is the way that it works as a conduit and feeds us through. And of course, at the other end, you're going to have your app, whether it's running on a server as a database or whether it's just feeding straight into a web page, whatever. That's actually consuming that data and making use of it. Okay, so in the end, it can be many things to many people, and the material, the next few slides I'm going to show you is really just the Things network I've ever kind of used it and manipulated it. I can't say I've come up for it, but this is how they and me visualize how the Internet of Things will work, and it's what I've just described to you. So here on the left-hand side, we've got devices. This one, the next one in is the gateways to the open world, then the cloud, and then not forgetting that, at some point you need to make use of everything that you've consumed. A lot of stuff, certainly when I started working on these projects, I really only made it up to here and made sure that it was all nicely sitting in the cloud. And I was like, yes, my devices work. But that's really not that useful if we actually want to change real lives and everything. We need to be able to present that data to them. And I think there's something that I've learned, and I'm not going to talk about it at all in this talk other than now, is it's really important to understand that whilst we may be able to look at graphs and actually just read spreadsheets or read data that comes through, when you're trying to take it to people who have got all sorts of things and haven't had that much technology experience and stuff, presenting it to them as that way is not a way that they can consume that data very easily. So that's just as important to think about, that we can generate huge amounts of open data, but if it just sits there on these cloud servers and it's just noughts and ones and that sort of thing, it's really not that useful. We have to be able to take that and present it to the world. And I do want to say that I think the open source community maybe has not been brilliant in the past at doing that, and it loves the technical side, not. But I think if we really want our thing to have an impact beyond the Linux and the cloud and stuff, then I think that's an important aspect to look at. And I need to do that too. Okay, so devices just connect things to the Internet of Worlds via the cloud network. Nothing really interesting. I'll show you what a device looks like in a bit. And gateways, they allow you to extend the reach of the network and so forth. And of course, the cloud is just really just like any other cloud service, but it's designed specifically in this case to handle the Internet traffic the Internet of Things traffic coming from these LoRa devices. And I suppose the real thing, it's only really useful, in my perspective, if we can make applications that are actually really making use of it and present it. They do use a phone for this. I have some troubles that they use it as their little icon Things network, because I think it should be more than that. It could be to produce reports. If we want to actually change legislation in the UK, then it's not about having phone apps, it's about actually producing reports and stories that we can take to the government or the council initially, is what we're working with, to persuade them to consider legislation against landlords who are not compliant to DAMP, for example, with respect to things. Okay, so that's more of a brief introduction to that, and I'm going to talk about now about low power wide area networks. So before we get to LoRa, I just wanted to introduce what I mean for this. So this is LP1. I'm sure many of you have already heard of this, but the key thing is that it needs to be low power. We really want these devices to be able to live out in the wild for potentially years, right? So Microsoft, I know we want to talk about them here, but they talked about 5 to 10 years would be a reasonable battery life for these kind of devices. I have to say at the moment we're looking at 2 years, because it's hard to imagine doing the same job in 10 years, or whatever. But realistically, we want them to be able to take them out, put them into the environment or whatever, and not have to. That's the critical thing, is not have to go and maintain them regularly. That's important as well, because we put these networks, these gateways up in Bristol, in Bristol, on Bristol City Council lampposts. And that was brilliant. The first time they were like, great. Then every time we wanted to go and modify them, they said it would be £100 just to get, or €100 or whatever, to get someone to come out with a ladder. Of course, we couldn't go up that ladder. They had to go up that ladder because of it. So, that's a real serious issue. If it's £100 every 2 years, that's maybe not such a big issue. But if it's £100 every month, or euros, then it's a real pain in the... Okay, so it's just basically a type of wireless communication, telecommunication network. I'm not going to go into that too much. And the critical thing is that it supports communication over a long range. Okay, so one gateway, and this is, looking at the numbers from this French company that I'll talk about in a second, could potentially be up to 10, 20 kilometers. Now, I have not seen any realistic, I think the best we've seen is maybe 2 to 3 kilometers, but before you start getting an RSI, that doesn't really look anything that's ever going to be useful, or just not getting any connection at all. And the way that it works, which I won't go into too much detail here, the further you are away from the gateway, the less the bandwidth, it's similar to what they do that, but they can reduce the... So, I've got to be honest, realistically, I think 2 to 3 kilometers is good. And of course, then you've got to have an antennae, full wave antennae that's very high up, no interference, things like that. So again, depending on your city, that can change. I'd be really interested if anyone is here from Amsterdam, how they found, because their city is so different from ours in terms of geography and the way the hills and everything. That'd be really interesting to see what they found for coverage. But, so it's not an idyllic world, you know. When you read a data sheet, everything's always perfect, you know, it all works at 3.3 volts until it doesn't, and that sort of thing. But it is pretty good. And it does, you know, the amazing thing about this, it does give you the idea that you could go out of an urban space. You know, you don't no longer have to be in an urban space to make this work. Potentially, you know, people have talked about doing it with rhinos. I don't know if it's just an advertising thing on their website, but they've talked about doing rhinos in Africa, or in Dublin. They've been trying to look at, or in Ireland at least, looking at dolphin populations and stuff and things. And you know, so it's beyond, it doesn't just have to be in the city. It can be beyond that. But it is very low bit rates. Okay, the bandwidth we're talking is pretty low, and so we're not going to be streaming high definition 4K video, but then, you know, that's not the idea of this thing, okay? Devices are operated by battery. Now, they don't have to be, absolutely. You know, we're doing this with the Bristol City Council. We're putting them around in these maps around the city centre. They actually use street lighting power into these maps, and so we debated for ages, should we just run them off batteries, but we couldn't really justify it when we could just get a 5 volt, you know, coming out. So, but the idea is that they can be run off battery, and the lifetime should be a good long time. Okay, so as I say, you know, again, these are just marketing slides from the companies or even from the Things network or whatever. I'm not making any claims so that you need to get out there and actually do measurements. We have been doing measurements, and the range is not quite what they're claiming, but you know, who knows, maybe you boost the signal or whatever. But here we're seeing that, you know, cellular networks, you know, how long the range is and how long the battery life is. Well, the range is actually pretty good for cellular networks, but battery, if anyone's at their phone, of course, if you turn Wi-Fi off on your phone, the battery might be better. Local area X rates, Wi-Fi is not brilliant for battery, but it does have reasonably long range, not brilliant. But up here, the low wide area networks, low power, is supposed to be the kind of compromise between these things. Again, it's always trade-offs, and you do that. And I think that, I don't know if you're aware, but Bluetooth is a technology that's been used quite a lot for Internet of Things, and people talk about it quite a lot. It's pretty nice because it runs at high frequency, so you get good indoor penetration, which you don't get with LoRa, for example. But the range has not been great. But then Bluetooth 5, which has just been announced, apparently 4 times the size of range, bandwidth is doubled. Can't get my hands on a device, so I couldn't tell you whether that's true or not, at least. But on paper, that's what they're claiming. So there's going to be some more trade-offs over the next few years. And there's absolutely lots of different technologies for these wide area networks, low power, wide. Sigfox is one, for example. And they all have different trade-offs. And I've got to be honest, I'm not going to talk too much about that in this talk. But I think LoRa is a good compromise between all the things about price, about range and power. Other people might argue different things, and so I'm not at all proclaiming that one is better than the other. Here, from a more data rate perspective, you can start to see that, you know, everyone's talking about, well, not everyone, but, you know, 5G at the moment, that seems to be the big topic in UK. You can get lots of money if you're doing research into 5G or you're some startup. So we're looking at these huge data rates and things, but it's point-to-point radio communication. You know, I don't know, maybe 100 meters. If it rains, maybe your signal doesn't work as well, that sort of thing. But you can stream 25 video channels at the same time, or whatever. God knows. Someone actually told me, they were in a startup company, and they said, oh, your application is that you'll be able to go to the train station and download 5 HD videos concurrently. Yeah, exactly. I tried to keep a straight face, but I honestly couldn't see what the advantage of that was. But anyway, we're not interested in that, and I don't work for that company, so there we go. And there's other network standards, HO2.11p, for example, is the IEEE Wave standard, which is looking at auto, vernacular. It's for vernacular networks. They're providing latency guarantees, not just bandwidth guarantees, and so that's important, I suppose, for cars that are driving around. You don't want them to crash. So again, laws are very specific, and the wide area ones that we're looking at are very specific for a certain range of applications. They don't solve everyone's problems. Oh, sorry. So it's based on radio modulation. So this is what, sorry, I think I've, yes, sorry. That's teaching me to have slides that go down and across. Okay, so just very briefly, we're going to talk about messy networks and why they're great for IoT. And what I mean by that, I'm not going to go into anything technical. But we're going to start looking at LoRa now, and we're just going to get a little bit of background why this works. Cell phone networks aren't messy, and what I mean by that, you need to very carefully place cell towers around, and in particular, there's a thing called minimal overlap. But the most important thing is that you care about this handoff, and the idea is that, if you're walking with your mobile phone and you're moving between one transmitter or receiver and another receiver, you don't want to drop the audio call, right? Because you know how annoying it is to drop an audio call. And so they spend a lot of money on this. It's really hard science. Hard science does cost money. There's no getting away from it, whether it comes from the government funding or company fundings. And these cell towers, if you estimate the cost, even though they might not cost 50k euros to build, in terms of research and everything gone into it, that's the potential what you're kind of talking about, or at least that's what they tell me. So these are not sort of things that you and I are going to be putting up around the space that much. IoT networks can be messy, and all I mean by this is that we can just stick gateways wherever we like, they can overlap, and they can, we don't care about handoff, right? And actually the way that it actually works is that you can often duplicate messages and the back end will take care of that and things. And the critical point around this whole point is that they don't carry calls. Okay, we're just sending data. And of course, you all know from your courses on TCP or whatever that, if there's a message, we just resend it. If we don't hear back, we can resend it, and we came up with some very strange network protocols to handle that. But anyway, it's important. And so that means that in reality, they don't really need to be very intelligent. And all I mean by that is that means they don't need to be very expensive. I'm not saying they're dumb, they've still got pretty smart computer chips in them that have done smart things over the years. All they really do is just forward packets from the devices to the cloud, okay? And okay, you've got all this radio modulation that's going on at a low level, but as most of us, well, don't really need to worry about any of that. It's interesting how it works, but really you can just see it as pretty much the same way that you would send and communicate on the internet and send over things, okay? So I think the implication of this is that with the help of open source hardware and software, we the people can build these IoT networks. And that's huge, right? That has a real implication, is that we can actually start to do it ourselves. We don't have to wait for companies like Orange or whatever to come build them for us. We can do them themselves. And that's what the Things Network actually inspired me with their work. That's exactly what they did, right? They went on Kickstarter and raised money to fund their first gateways around Amsterdam. I can't remember how much, 12 maybe initially, I can't remember. And now I think they're up to 39. But you can do it, right? And it's had a real impact. And actually, not only did that work have an impact, building them in Amsterdam, it had a real impact on me because it encouraged me to do it, right? Okay, so that's what their big logo is. They're great, and one day I may even get them in. But anyway, let's talk about, that's so annoying. Let's talk about LoRa and LoRaWAN for another little bit. Okay, so LoRa is based on radio modulation technology developed by a French company who were acquired by Semtech in 2012. And I've got to be frank with you, this bit of the stack is not open source. I expect, I've never checked it, they've got lots of patents, and you wouldn't be able to hack it. I'm not that interested in hacking that, yes?
There was an interesting talk where they did reverse engineer.
Yes. Yeah, so he's saying that there was an interesting talk at a group who reverse engineered LoRa, and you can see it's online. There's a couple of people who have built SDR systems to do that, so you can do it absolutely. And it's it's not that complicated, and certainly if you're interested in radio technology, but I'm not sure that we'll be able to go out and build products without them maybe getting a bit annoyed at us after a while. Certainly, too much. And to be honest, we live in a world where, I've got an Intel chip in here and stuff. I use a lot of open source software if I can, but I'm not going to tell you I use only open source software. OS X, for example, is not open source. Okay. So we've got these chips, okay, and that little bit is closed, and we've got everything. But everything above that is pretty much open. So, for example, there's the LoRa Alliance, and they've developed this thing called LoRa for Wide Area Networks called LoRaWAN, and it's basically just a MAC layer to standardize and extend the physical layer. That spec is open source. You can implement it yourself. You can buy a chip, which I'll show you in a bit, for example, Microchip. They just run on M0 in here as a software stack. ST have a similar thing which they've just announced. They have Yeah, someone's got one there. And you could write that stack yourself, right? It wouldn't be a trivial piece of work, but it wouldn't be that hard, no more difficult than writing an IP stack generally. Okay, so the specification is open sourced. Key features. So it's end-to-end encryption and security. So this is really important. There's a security organisation in the UK, ARM and others are funding, was saying the number one concern about IoT is security. Security is their motto or whatever. And clearly, it's incredible how many devices. There's an electronics store in near where we live called Maplin's, which is a bit like Radio Shack, I suppose, although not as good. And you can buy a carp, a fish, it's a carp. And God knows what it does, but when you get home, apparently, you're supposed to get a little app, and you connect that carp to the internet. I don't know, maybe it sends humidity or whatever, who knows. But someone showed me it snooping that thing whilst you're onboarding it. And lovely little text messages with your, like literally had a console snooping it, nothing, no thing, and there it was, just in asking, you know, your password. And then the person then connected to Google and put their Google account in, and there was the password. I mean, that's insane, right? And when we all, I mean, it's just, yeah. Okay, so security is really, really important. LoRa has it built in from the ground up, and that's great. It has adaptive data rate optimizations, which means depending on what you're saying, it can also be used to how far away you are from gateways and stuff to adapt it. It has quality of service, although there's 3 different types of devices that can connect to LoRa, and I think that Class A, which is what most of us have been using to date, doesn't have that quality of service, and it's only in the 1.1 LoRaWAN specification where they've started to allow Class B, which does have this, and that will be important. It's unfortunate that at that moment, when they did that, they then started to talk about going to, that's one of the things about LoRa, it's in unlicensed spectrum at the moment, and so that's the advantage, but they're now talking about going to licensed spectrum. At least that's what they mentioned, and they said maybe one day we would. That was in their tweet. And I don't know what the implications are. That concerns me because then maybe it's not open to all if they do that. I don't know what the actual implications of that are, but there are some concerns. Okay, laid out as a star of star topology. So this is really good for mesh-based networks and these sorts of things. And they claim it's the best compromise between a range of communication, so the amount of communication, number of base stations, gateways, you know, so you can minimize how many you could have, for example, and device battery life. And obviously, clearly, these are important because we'd like to minimize the number of gateways that were actually necessary to deploy to get to cover a region. And, but at the same time, we also want to make sure that device battery life is great, and that has an implication on how your range and what bit rates you're sending at. So, the communication between the device and the gateway uses spread on different frequencies and channels and data rates. It uses frequency hopping and other techniques to do this. It's all very not straightforward, but it's the low-level radio side, which I'm not going to go into too much. But it gives a reasonable range of bits per second that you can do transfer at that range. It is important to know that we are talking about very small amounts of data. You know, we're not going to be sending high amounts of data per package. Adaptive data rate means that it can manage databases of connected devices as they go, dynamically. And the end device, so it changes channels every time it tries to send a packet. It will change channel in a pseudo-random fashion. And the most important thing about this is that it ends up providing diversity within the frequency range of the region that you're in. So hopefully that would portend robustness against interference. Now, of course, just like any system with radio, you are going to get interference, quite potentially. You know, it's interesting. We have about, I think, probably about 50 known devices that are live as part of this council project that we're doing in Bristol City. So you're not going to get much interference. But they claim, Semtech and other LoRa Alliance claims that you could have tens of thousands of devices communicating with. And I'd be really interested, you know, we haven't had that many, you know, what's going to be the implications once you have that many devices? And if you really want the Internet of Things to be successful, potentially we could have that many devices. Okay, so the bands, ISM bands, they vary depending on your region. As I said, it's all unlicensed at the moment, and so for us it's 868 and 433. The US and Asia are slightly different. I've got to be honest, we haven't been using 433 at all. I just use 868 and that frequency range. Because it's unlicensed, it does give you some restrictions, okay? So it gives you, your maximum duty cycle is limited to devices of 1% and 10% for gateways. So that boils down to, Things Network, I've forgotten what they call it now, but they have a fair use policy, effectively, because where they say basically that they'll restrict devices to having maybe 30 seconds of online time per day. If you work that out, there's still quite an amount of data you can send, particularly if you imagine that you're only sampling every 5 to 10 minutes. But that's encoded in their back end, right? The gateways will propagate that information and not allow devices to do that. So they call it a fair use policy. And again, we'll have to see how well this scales, and particularly if we want to see industrial applications. So it's a fairly standard thing that you'd expect. You have the physical layers at the bottom here, and basically you have these layers. Normally it's done by SPI, and that's just the way that Semtech have exposed their radio chips, and then they have these software stacks that sit up here that actually do the communication. So here's your sensor, your gateway here sits in the middle, there's physical to physical communication. One of the really nice things I should say about LoRa is that the chips on the device and on the gateway are the same, the chip for the radio. So that makes it really nice in terms of, you obviously have, it's weird the way that Semtech have done it. You have to get this chip, but then you have to build all your noise reduction and things, break out yourself, and so it makes it quite hard to actually build, unless you're good at that sort of stuff, to build your own PCB specifically for the radio. But that aside, it does keep the costs down, relatively down. They're about €8 for a fully front-size stack, including the M06 on here, for example, compared to something like Sigfox, which the devices are really cheap, but the gateways are actually very expensive. They don't have the symmetrical chipsets. So as I say, LoRaWAN chips, they're pretty low cost. Just for a single one, right, they cost around €8. And if you imagine, obviously, if you were buying them in bulk in the thousands, then that price would drop considerably. Okay, so the chips that we've been using, which again, many people on the Things network have been using, I believe, and they recommend them and get lots of devices, are this microchip here. It looks quite nice with this little bit of metal. I don't think it's really needed. But inside there is the LoRa chip itself, the physical radio chip, plus an M-Cortex, M0 Cortex, which runs the software stack for the LoRaWAN, and so on. It's not hugely complicated. Most of the chip is going to be handling the different bands and the noise reduction and things like that. So it's not that complicated. There are other companies that do it. ST, I know, have announced one. I don't know if you can buy it yet. There's another company, I can't remember the name, but they do a very similar chip to this, and almost all of them are just programmed by a simple serial protocol. Just break out TX and RX, and you can clock it if you want, but to be honest, it's really straightforward. It's so straightforward that this is a piece of code that I grabbed off the internet last night when I was writing this, on Thursday night, from an example that the Things network put up for their little Uno compatible board that they have. I'll show you, and it's really, this is a slightly cut down, but it's pretty much it, right? You use a software serial library, and then you get your header file where they've implemented the commands for the RX-TX chips. It's as simple as initializing the radio. You simply join the network. You can do not over-the-air activation, but I really recommend that that's the way to do it, and Things Network argue that this is where you should connect. So it just means that as you connect your device to the network the first time, it will set up all the keys and connect and so forth and things. And I'll show you a little bit in a minute, there's enough time, but you have these nice unique IDs. Each device has a unique ID, and then the application. What I mean by that is that you can have many devices connected to a single application, maybe one that's gathering information about damp sensing, for example, and that each application has a unique, and this will connect both the device and the application to the, will connect the device to the Things network and the associated application. So you're right there, and then you can start to read that information fairly straightforwardly. It's very simple. And then you're at the bottom here, just TXing. And if you're interested, you can look at this library, and we're talking, it's a few thousand lines of very simple C code, you know, or C++ code, because it's stolen from Arduino stuff. But it's really basic stuff. There's nothing going on here. I mean, the protocol for doing the serial protocol is, you know, it's just basically 8T commands, you know. Okay. So it's really, really easy to build your own device. So certainly for the people in this room, maybe not, you know, for my 4-year-old son, but, you know, he'll get there soon, hopefully. But it's really easy to build your own devices and, you know, pick yourself up an Arduino or whatever. I mean, we don't use those particularly. We'd use ARM chips, just a bit more interesting and robust, but they're great for getting going. Buy one of these microchips. You can get little breakout boards. We did our own one, but they sell them online for like $2 or something for that chip, and then you wire it up and then program it basically with that piece of code that I just showed you. It's very straightforward. Okay, or if you really don't want to do that, then there's lots of great off-the-shelf ones. I'm putting the Things Network Uno board up here just because I'm talking about them and they need a bit of promotion. I think that's great, but there are lots of other ones. Some of them incredibly expensive, like the Solec one, and the other one's actually really cheap. And he's not here today. He's supposed to come, but a student of mine, we've built our own board. And you know, if you're good at PCB layout, which is not that difficult, and you're willing to send it to China, you can build your own board, but pretty darn cheap. And of course, you get it to do exactly what you want, you know. So, okay. So I've talked about the devices. I'm just going to spend 5 minutes or so talking about the gateways. And so this really comes in with the Things Network. Before that, all that device stuff we did, other than the bit of software I showed you to run, which did know about the Things Network, because I stole off the Things Network code, you could really, this device could connect to any LoRa network, any gateway, right? But once it gets to the gateway, then really, then you're talking to the backhaul and it needs to know where to go. Okay, and so this is where I think the Things Network, or whichever network you're using, could build your own if you wanted to, comes into play. And so I'm going to put their slide up there. And again, we'll come back to here. So we're now talking about these blue boxes in the middle here. And in particular, this is what this looks like from a perspective. That slide's a bit dark, isn't it? So we're just going to look at the bit in the middle here, which is effectively, it's just a piece of code that is reading from the physical layer up. It's translating what it reads into an IP packet, and then it's forwarding it from. And if you actually looked, if I could take, oh no. So, it's not there now. Is it there? Oh yeah, here's Atom. So, and this is actually the code. It's called Poly Packet Forward C. I'm not going to go into this code in any detail. 2,000 lines of code, and this is the whole thing that runs on the gateway. Right, it's just a thing, and it connects to that. And there's just a couple of threads. There's one that's, it requires that you read GPS locations. There's one that's doing that. And this one here, if you looked at it, it's about 200 lines of code. It's basically taking the radio, reading from the radio via SPI, and then just sending it, you know, turning it into a packet, adding a bit of information about the gateway and that. And it's really basic stuff. And I don't know what the Things Network have done. They've tweaked it a little bit, but the actual code is basically the reference code from Semtech. And they may or may not have added stuff. And I've never really spent much time looking about what they added. I've looked at the code, but not that. But it's very straightforward stuff. So it's really easy to build your own gateway. Here's a Raspberry Pi. You can get those for 30 euros or whatever. And here's a i280 card, which if I turned it over, you'd see all the radio stuff on it, basically laid out. This is specifically for a gateway. It's the SPI variant. They have a USB variant as well, but I prefer SPI. And so do that. And literally, if you know what the pin patterns are, you can set this up in 5 minutes, download the software, and you're off, and the gateway's running, literally, I would say, in 20 minutes. Well, certainly, once you've done it the first time, maybe the first time took me a couple of hours, I admit that I read through all the instructions, but now I can get it down to 10 minutes. You know, it's really very easy. And I didn't change a line of code for the first 4 gateways that we deployed. Just purely relied on the work that the Things Network had done, which was great. Their documentation was a little bit hard to get through because it was in weird places, but take that aside, it was really helpful and I did it. Okay, and we were off. It's all open source, Raspberry Pis. The hardware, again, not open source, but you know, all the software stack is. And literally, you can build it for approximately about 200 euros. And that was including postage and packing to the UK. Initially, my gateways only had antennae like these. You'll discover that these aren't that great for if you want to get a nice bit of range. And so we do use full wave for our deployments around the city. And that costs as much for the antenna than it does for that software. But it really depends on what you're trying to do and what kind of reach you're trying to do. So, not that many slides now, I'm just going to finish up. So this is what the Things network really looks like though inside, right? So we've got our nodes, we've got our gateways, and the real work that they've done, I'm not saying all of it's great what they've done, but the real complicated work, which has taken me ages to start to get my head around and actually wanted to modify the source code, is in their back end. You know, the cloud, they've got a pretty nice cloud service, and they have a bunch of things where they're working out where to send it to, and things like that, where they're brokering, and then they have a very standard web application interface, which is just accessing their database to give you a view. But what they're really providing in the middle here is bits of code, you know, MQTT or a node interface for getting the data out of their databases into your system to take that on. And they have a nice, if you want to just test your back end or your application, then they have these TNCTL tools, for example, which allow you to emulate or fake sending up data to the system without having to have a device connected to the gateway. So it's really nice because that means you can then test your system, you know, in a nice orthogonal way, make one bit's working, check the other bit's working, and then bring them together. Just standard stuff, but it's still really good. Oh, there was a picture there that I no longer have, sorry about that. Okay, and if you wanted to actually, once you've got all this stuff and you've made it work through the Things network, if you don't care about the Things back end and the actual how they implement it, then really you can just look at that as a black box. Most of that diagram I showed you, you could just ignore. And then if you're familiar with Node, you can very quickly on your machine write a trivial piece of Node code. This is actually a complete thing. You notice I've got the app EUI up there and the access keys up here. I connect to the Things network with a TTN Connect. Remember, this is not connecting by gateway now, so connecting via the cloud. And then you have these three callbacks, which you can basically, you get message on, you know, when it's activated, blah, if there's an error. And the most useful one here is just this line here. Every time your device sends some data to the Things network, this callback will be called. Okay? And then you're just in your own application, you're doing your own stuff, right? I mean, what's this, 20 lines of very trivial JavaScript. You know, I wouldn't write it with JavaScript, I'd use TypeScript, good little bit of promotion of TypeScript there. I can't stand JavaScript. And, but it's really simple, right? MQTT, I must admit I don't use that very much, but if you're into that, then that works too. And you're then off and going, building stuff that's actually useful to real people and doing stuff, so it's great. So I've only got a couple of minutes left, so I'm just saying, this is actually almost it. So in Bristol, it turns out, 5 bikes are stolen every day. Well, this is a fact from the Evening Post. We know how newspapers like to present false facts, but let's just assume this is true today. And, well, it seems that way, doesn't it, anyway. But here's a little diagram I drew when I was thinking up this, and, you know, bikes, we could stick something into the frame so it couldn't get stolen itself, and then you could track your bike using GPS and accelerometer and LoRa. Really simple idea. You can do that. And Josh, who's just there, is a final year student. He took this and ran with this idea and has set up a really nice little demo that we can look, and this will be the end of my talk if we can get this to... oh, come on. Come on. The best thing about working at the university is you get edge-on access, and so it works everywhere, but now it doesn't. Has your server crashed now? That's it, isn't it? Your server's crashed. Anyway, if I was going to show that, you can see that how he's designed it. I mean, he's designed a little bit of hardware to do all this stuff with the LoRa chips and everything, but he's also designed a really nice little interface just using Google APIs and the GPS data that he's getting that will show you the bike as it moves around, you know, and tracks it and everything. And you can see the device IDs, and literally, you know, you start monitoring, it connects via a node to the TTN network, and then basically starts to consume that data and show it. It's really simple and really useful. You know, it's an actual useful application that you can do to monitor things and so forth. But anyway, I'm really sorry that hasn't worked. This project is running under the hat called LoRaWAN Bristol, so this is a whole, we have a whole infrastructure going on for that, and it's not just me. It started off with me, but I've reached out. We have a bunch of other people, both business people and people from research, both universities in Bristol, that are now working on this and trying to make it a reality beyond just the 2 gateways that I initially put up. And maybe I won't have to pay for all the future gateways. That's what I'm really hoping. That's the real reason, but you know. Okay. So it's for the Bristol, at the moment it's for the City of Bristol, it's free for all, and you can go and find out more information at that website. But I realise that I've only got 5 more questions, so I'm going to stop right there. Okay. Okay, he's going to give you a microphone, I think.
If you connect to the FOSDEM agent, it will probably work.
If I connect...
If you connect to the other VLAN.
Oh, okay. All right, I won't worry about it. I'll take some questions. So, there's a question back there.
Hi. So what kind of distances are we talking about if we drop the dedicated antennas on the client? If we drop the big dedicated antennas.
So we don't use the, you mean use something like this instead?
No, without, is it possible to have a small antenna embedded on a PCB?
Well, PCB printed, I'm not sure they're so good actually with LoRa because of the way. It does work, I've got it working, but it doesn't seem to get that great distance because particularly in penetration. So it varies. So one of the reasons that we put up the big antennas is that, with the full wave ones, we're at high, they're running at 12 dBi and everything, is that means that you'll get, your other device is going to have much smaller. You know, they can have quarter wave and they can be further away, and you kind of trade it off, right? And so you could still be talking, I don't know about the PCB ones, I've got to say, but we've been using the small ones, the quarter wave ones. Pardon?
The bulbs of the engines.
Yes, yeah. And we're still seeing, say, around, and this is unscientific, you know, I've been riding around on my bicycle to pick out these values, so I'm not going to make any claims other than 1.52 kilometers. So it's still not too bad, but it doesn't meet these 10 kilometers or 20 kilometers, but maybe if you were carrying around a full wave in the device, maybe that would give you that, but yeah, but that's the sort of range. Yep.
Thank you very much for this great talk. You mentioned that you can use the same chip on the node and the gateway, but does this apply for multiple channels? From my understanding, you can only have one channel at a time.
So when you say one channel at a time, what do you mean?
So on the gateway, if you want to listen on all 8 channels, if I recall correctly, can you do this with the same chip that you use on the node?
Well, there's 2 different types of chips, right? One only does it, you're right, there is a one chip which only does, listens on just the one channel, yeah, that's the cheaper one. And then, but if you get the other one, that will work on multiple. Now it's true, there's less reason why you'd want to have that on the device, that is true, yes. So that is true. If you want to listen to all 8 channels concurrently, I think you do have to have the slightly more expensive chip, although it's not that much more expensive, I don't think. But anyway, but you're right, yeah, absolutely.
Since you already have M0 MCU on the radio chip, can you use that for application code, or do you have to add?
So that's interesting. So some, you know, like the Nordic Bluetooth chips, they do allow you to break that out, don't they, and do that. As far as I know, this chip does not allow you to access the pins. Although actually, no, it probably does. I've just never done it. So I think it probably does, yes. But I have to say that the WAN stack takes up quite a lot of space, so you're not going to get much, depending how much memory they've got. But you could probably do a couple of bits. Yeah, probably. I don't know. I've never done it, but I don't see any reason. Yeah.
You want to?
Just wanted.
Hi. I'd just like to remark that in the Netherlands we have already quite extensive network of this. And there's a website called ttnmapper.org where you can look up if there's a gateway near you, and you can also see the signal strength.
I'm sorry, I find it very hard to get what you're saying.
Sorry, there's a website called ttnmapper.org.
Yes, I know that, yeah.
And you can, if you're curious and want to play with it, then you can look up the locations of the gateways on that website.
Yep.
And also see the signal strength.
Yeah, thanks. So he was just mentioning that there's a website, TTM Mapper, which will plot different gateways in different locations, and I use it a lot. And I should have mentioned that, it's really good. And yeah, you can just get to it, just Google it and you'll get to it. Okay.
Anyone else?
Over there. Sorry.
A couple
questions about the software stack side of LoRaWAN. So in particular, since you mentioned the Raspberry Pi earlier on, I've noticed that you're right that there's a lot of code to be found on GitHub that you can just check out, download, and run on your devices, but many of those are using incompatible license. Like in particular for Raspberry Pi, they're usually always using the wiring Pi library, which is under LGPLv3, whereas the LoRaWAN stack is actually under some GPLv2 license, which is mutually incompatible. So I was wondering, in particular with a view on Linux on the Raspberry Pi, is there any work going on for writing like real kernel drivers for LoRaWAN?
So that's a really good question, and I have noticed that. I have to say I kind